Hello, welcome students. We are going to be talking about the different trig functions, as in all of these beautiful ones, and we are going to be talking about inverse functions. Okay, so the first video will be covering other trig functions and their graphs, and then the second video will be about inverse trig functions. So what we are going to do today is go through our notes, and our notes are going to just briefly cover this. So tangent of x is actually the one that probably you need to know: sine, cosine, and tangent. The other ones flow out of these, but I have provided the details on this. So we'll expand this so that you can see what the different aspects of the graph are. Now, do you need to know how to graph it? Not exactly. You do need to know some key features. So let's look at the key features. So let's back up a little bit, There we go. Okay, so first key features we need to know. We need to know the period is pi. So that means tangent is going to repeat every pi. Okay, from 0 to pi, repeats the same place, and it does, and so do its asymptote. Now the domain is all x except pi over 2 and every pi over 2. So pi over 2, negative pi over 2, negative 3 pi over 2. These are asymptotes, as you can see here. Our range is from negative infinity to positive infinity, and the symmetry is over the origin. So if you flip this over the origin, you would get the same exact functions. Okay? Okay, so what about cotangent? Now cotangent is just is a vertical translation, a horizontal translation of tangent, and it is a reflection over the x-axis, over the y-axis. So it's reflection over the y and then translation. So it is pretty simple. It's all x except pi and pi. It has the same period as pi. It has the same range, as you can see, from negative infinity to infinity, and its vertical asymptotes are every pi. So where tangent is every pi over 2, cotangent is every pi. Okay, and its symmetry is over the origin. Now we're just going to go through these pretty quickly. Reciprocal are cosecant and secant. So cosecant, as you can see, it is the reciprocal, meaning as sine decreases, cosecant will, as sine decreases, cosecant will increase. As sine increases, cosecant will decrease. Okay, and its domain is everything but pi, because obviously sine of pi is 0, and it has a 2 pi period, as in it's related to just sine. So it has the same period as sine. Okay, and then this is its range from negative infinity to negative 1, and from 1 to infinity. Okay, vertical asymptote at n pi. Secant obviously will have similar features. 2 pi, it will be the opposite of cosine. And the domain is everything but pi over 2, because cosine of pi over 2 is 0, so secant would not exist at that point, or rather be undefined. Okay, this is the range, again, the same range as cosecant. Vertical asymptote of pi over 2 plus n pi. Okay, so it repeats at pi over 2. Okay, that is it for those graphs. So briefly looking at this, we want to just trace one of these. So let's trace tangent for a second. Now, as you can see, tangent, actually its x values are following angles, and its y values are the ratio of the sides. Okay, so as it approaches pi over 2, for example, the y is going to keep growing, so then y over x is going to go larger and larger. Okay. As it approaches 0, its y value will decrease and the x value increase, so we will get closer and closer to 0. Cotangent will again follow something similar to this, just shift it over and reflect it. Now, so if I wanted to show you, if I did this, I believe plus pi over 2. Let's see if I'm correct. Oh, sorry. Not plus. Sorry, it has to be the x. I want to test this out. Let's test this out. Plus pi over 2. Okay, so as you can see, there is no distinction between translation and reflection of tangent, cotangent. Okay, so that's just to show you that those two are related. Cosecant and secant actually are also translations of each other, but as you can see, cosecant is going to be rooted at 3 pi over 2, pi over 2, but its asymptotes are 0, pi. Secant, again, will follow cosine, so its asymptotes will be pi, 0, related pi, but its asymptotes will be pi over 2. Okay? Simply put, that's how you would look at it. Now, will you need to graph these for the test? No, so don't worry about that. In the meantime, what I would say is just focus on this inverse section, okay? Okay, so definition of inverse. So an inverse function is if for every x in the domain, f of g of x equals x, and for every f of x in the domain, this is true. Okay, so that is a composite function. Basically, if you take the composite function, it should just give you the x value. Okay, so this is a definition of an inverse. Now, requirements for inverse functions. Remember, it has to pass the horizontal line test. So remember, function has to pass the horizontal line test to have an inverse. So we're going to have to restrict domains of trig functions. Okay, so we're going to have to restrict our domains. Now, what domains are we going to be restricting? Well, okay, so in this case, we're restricting sine. What's our restriction? Well, this is pi over 2, and this is negative pi over 2. So why are we restricting it to this area? Well, again, do the horizontal line test. If the horizontal line test, let's transition. Okay, so if we did the horizontal line test on this sine function, it would pass it, right? The horizontal line would only go through one point. Okay, but what if we go down again? Okay, well then the horizontal line wouldn't pass it, right? Because it would pass between 2 points. So then we can't go past our maximum, and we can't go past our minimum because, again, then we don't pass the horizontal line test. Okay, so horizontal line test only works in between half of a period, right? Between one min and one max. So the easiest way to do this is between pi over 2, negative pi over 2, to pi over 2. Could you do a different section? Yes. Okay, but the idea behind that is that you're increasing on this domain. Okay, I don't think that's true. Okay, so something like that. It's not a beautiful graph, but it is what we can work with, understanding that we have to restrict our domain. Now, and cosine, again, also is restricted. So cosine is going to be restricted between 0 and pi. So cosine is going to start with its max and go to its min. So again, 1, -1, pi, and pi. So something like that, that's going to be cosine. Obviously, mine's not exactly accurate, but you can get the picture. Okay? Okay, that's our restricted domain. Now, tangent, you just restrict it to one between two asymptotes, and you can do tangent. Okay? We will go on to the inverse sine function and finding exact values in the next video. See you then.